Yes, let us start our discussion about stacks and queues, right? Yes. So, what do we hear about when it is a stack, and what do we hear about when it is a queue? Let me tell you that, right? So, firstly, what is a stack? Now, imagine you went to a marriage or something like that, then you see all these chairs, right? So these are your chairs. Now, these chairs are one upon the other, one upon the other. Or you can take any elements like this is one, and then two, and then three, and then four, and then five, right? So one on the other. This is known as a data structure, which is called, as a stack. Now, you might say, what are the operations that we can go with when it is about stack, right? So, let me tell you what is that. Firstly, if I want to remove one element from this stack, how can I remove it? Right? How can I remove it? I'll remove the one which is on the top, right? The one which is on the top, I'll be removing that first. Now, how can let's do that. Wait a second. So, yes. So, okay. Let us see how can we remove the first element from the stack, right? So if I have to remove the first element or the top element, I can remove it. Easy. But can I remove the element which is in the middle? No, I cannot, right? So if I have to remove it, there are two elements on top of it. I cannot remove. So that's why I'm saying that imagine that as a chairs, right? Hello, Rishi bro, hello. Thanks for watching this live session. So to remove, I need to remove from the top. Now, can I push this into the last one? No, I cannot. I can only push this onto the top. That's it, right? I can only push this to the top. Yes, I think. So if you have any doubts, please let me know. I can only push the element into the stack from the top. So that's why the one which is the last one. This is the last one, right? Now let us see. This is the last one. Now, if we have understood this, what is it called? LIFO or FIFO? Let me know in the live chat. If you think this is FIFO, please do the comment in the live chat. Rishi bro, LIFO, right? Okay, you are saying that last in first out. So let us see. Is it a LIFO or FIFO? LIFO is nothing but last in, last in, first out. FIFO is nothing but first in, first out. These are two operations which we will be doing on stacks and queues. So if you think it is LIFO, please let me know in the live chat box, or if it is FIFO, let me know in the chat box. You can comment LIFO or FIFO, right? If it is LIFO, so what are we doing actually here? If you see, this element is the last one which I pushed back. The last one I pushed back is the first one that I am removing. The last one is is the one which I am removing the first. Let me write it here. Wait a second. The last one which I pushed is the first one I remove. So instead of writing it as pushed and remove, let me know the last in will be our first out, right? So let us extract our principle from this. So last in, the first out. The last in element will be the first out element. Let me write it. Last in, first out. So this is about stack. Now let us see what is it about. Queues, right? Let us take an example. Let us see that you are at SDI bank and that person has some of these uh, things to do, work to do. So now you are one of this person, right? Now let us take this is you. This is you. Now the one which went first is the one which went first is this person, right? I think I am right. This person went first. Now, you went at the third position, right? This is first, this is second, and this is the third position, right? Okay. Now, this bank is saying that, so this person here, this bank officer has asked him to come. Now, this person has went. This person has went and asked for balance inquiry or something. Then this person was out. The first person, let me write it. This is the first person, this is the second, this is the third, this is the fourth, this is the fifth. Now, the first person went to the bank and inquired about something or something like balance inquiry or to issue a loan or something. So he went first, did his job, asked about, inquired or something, then he went. Let me write that down. So the first person went and did his job. So Rishi bro, you have said LIFO for stack, right? Yes, it is correct. Okay. Now let us come to the queues, right? This is just a queue in SDI Bank. Now the first person went and did his job. Okay. Now after that, after that he left. That's it. Now imagine, just imagine your friend or your brother, something like that. Your brother has came at the position of 6. He is the last person. Will he goes to the bank directly, to the bank officer directly and ask to do his job? No, right? What do you think? If the person who came at the sixth position, the one which is at the sixth position, will he go to the bank and ask for to do his something like inquiry or to withdraw his money or something like that operation? No, Will he do it? What are your comments on this? If a person who is coming at the last, will he go to the bank officer and ask for inquiry or some service? No, no, right? No, even if it is not a lunch break, they will not agree to do that, right? So, if a person coming at the last will not go directly and ask for any service. Now, the one which comes at the first goes to the bank officer, and after that he left. Went. Let me change that as first person in and did something like you can write whatever it might be, and after that the service balance inquiry or something. After that he was out. Let me write it. The first person in and out. Right? Now, he will not wait until your brother and inquires in the bank or does his job. No. The one which came first will go and ask about the inquiry or service or something, then he leaves. The first one in, and that's only the first one which will be the out. So, this operation, what do you think about this uh, principle? Let me know in the live chat. What do you think about this person going to the bank and then leaving early? Right. Let me know in the live chat. Okay, the first person was in and did his job or inquired about balance and something like that. So please don't hesitate to comment or post your comment in message in live chat, right? So the first person was in and he was out. The first person to go out. So it will be FIFO operation. First in, first out. So this is FIFO, FIFO operation, first in, first out. I think we are clear with stacks and queues. Now, where do we implement this, right? Let me tell you why and where. Let me know in the live chat, do you have any idea about where can we use this, uh, why and where these stacks and queues are used? Stacks and stacks and queues. So for stacks, last in, first out. For queues, first in, first out. Right? Let me know in the live chat. Right? So what are the uses for this? Where 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 do we use stacks and queues in real life? That means like where do we use in our computer science, right? Where do we use stacks and queues in real life? Let me know in the live chat. Right? Okay. Let me know in the live chat that uh, where do we use these stacks and queues in real life, right? Okay. Rishi 66116. Okay. where can we use this live, stacks and queues in real life? So let us start with this. Where can we use it actually? Let me tell you that. Let me see that if you think, right, you have opened a tab in your web browser, and let me name the tab as tab 1, and then tab 2, and then tab 3, like this. You have opened three tabs in your web browser. Let us think like this. Okay, you have a web browser, you have opened tab 1, tab 2, and tab 3. Now, you have closed this tab 3. What it will do, you have closed this tab 3. Then, you have closed tab 2. Then, how can we, if you, I think many of you know this. So, to open the previously closed tab, closed tab in a browser in Windows, actually, you need to use this command. So if you don't know, let me know in the live chat. Control plus Shift plus T. So if you let me tell you that you can you can open a tab and then close the tab. So if you want to reopen the previously closed tab, then you can use this Control plus Shift plus T. But have you ever wondered where are these storing? How can a browser can store these tabs which I have closed recently, right? Where is it storing actually? A browser, where is it storing actually? And it is also in an order, right? Now, first I closed tab 3 and then I closed tab 2, right? So, if I give the command of Control plus Shift plus T, what do you think? Which tab will open first? Which tab will open first? Whether is it tab 2 or is it tab 3? I have closed tab 3 first. First, I closed tab 3. First, I closed tab 3. Then I closed, excuse me. First, I closed tab 3. Then I closed tab 2. If I, if I press Control plus Shift plus T, which tab opens first? Which tab will be opened first if I closed tab 3 first and then tab 2 first, right? So that's what my question is. Let me know in the live chat in comment section, right? Tab 2 and tab 3. So this is the day 7 of 30 days DSA live grind. So today we are discussing about stacks and queues, right? So do we have any Telugu speaking people here, like from Andhra Pradesh or Telangana? Like the thumbnail which I have used is a is from a movie poster of Telugu. So let me know in the live chat. Do we have any person, Telugu speaking person, right? Okay. So first I closed tab 3, then I closed tab 2. If I press Control plus Shift plus T, which tab opens first? That's what the question is. Let me know your answers. I'll be waiting for 2 minutes. So that's the easy problem. Easy question, right? That's an easy question. Okay. Okay. Let me tell you this. That if I closed the tab 3 first and then tab 2, so the recently closed tab is tab 2, right? So the tab 2 will be took from the stack. The topest element is tab 2. It is pushed back, nothing but it is retrieved and then given back to the browser. If I give the command again, Control plus Shift plus T, then tab 3, right? So first it will be the recently closed tab. The recently closed tab is tab 2. Then after the recently closed tab is tab 3, right? So this is how it will be. Let me show you. I'll be just opening something like google.com. Okay, news.google.com. Let me open Google. Okay, right. Let me open. Let us open like okay, Guns N' Roses OJ. Right. So this is tab 1, this is tab 2, and this is tab 3. I said I close the tab 3 first and then tab 2 first. So I am closing tab 3 and then I am closing tab 2, right? I said I closed tab 3 first, so it will be in the stack, then tab 2, so it will be in the top of the stack. Now, if you see the tab 2 is, I think it is, let me tell you, what is this tab 2? I'm pressing Control Shift T. So the tab 2 was google.com. If I press this Control plus Shift plus T, then I got Guns N' Roses OG. This is the search I have given in Google, right? If you see, tab 2 came first. This is our tab 2, Google. That came first, and then tab 3 came next. Tab 3 is nothing but Guns N' Roses OG, right? So I think you understood this. If you have understood, please let me know. And if you don't understood, also let me know in the live chat, right? I think you have understood what is, how can we use. I think this is a classic example of where we use the stacks. So it will be used in a browser. It will have this tabs closed, right? The recently closed tabs. Yes. So I think we can go to the next one. The next thing which I want to explain you is where queues are used. Where queues, the spelling is wrong. Queues are used. Where does this queues are used? Let me tell you. Okay, imagine in CPU scheduling. CPU scheduling. We got, it will be in OS also. So in CPU scheduling, we got this this thing like first we got operation. This is nothing but let me tell you this. This is something like a queue. However, in CPU scheduling algorithm, the one which came first, the one which came first, this is operation one. Operation one. Okay. Then I got operation 2. Then I got operation 3. I want to do all these operations by CPU. I think processing unit. You might all know what is the central processing unit is. And then operation 4. What do you think which operation will be executed first in a like first in first out algorithm? So the one which came first is operation 1. So the operation 1 is selected and it is executed and removed. Then the one next, operation 2, it is executed by CPU and then next. Operation 3, it is took and executed and then next. Then operation 4, it is took and then executed and the next. I'm giving 2 minutes of time. At the 8:45 we'll be solving stacks and stack problems actually. So let me know in the live chat if you have any doubts. So at 8:45 sharp, we'll be starting problem solving, right? If you have any doubts, let me know in the live chat. Okay. Okay, we'll be solving valid parenthesis. Let us see what does this problem states. Given a string S, just the characters, uh, just containing just the characters, open bracket, closed bracket, open floor bracket, closed floor bracket, and then open, what do you see? Square bracket. Okay. Open square bracket and closed square bracket, right? Determine if the input string is valid. An input string is valid if open brackets must be closed by the same type of brackets. Open brackets must be closed in the correct order. Every closed bracket has a corresponding open bracket of the same type. Okay, I think you have got it. Okay, what I think is we can understand this better if we take the example. First example S is equal to one open bracket and one closed bracket. So the question number is 20 valid parenthesis. The question number is 20. So if you have any thoughts or suggestions, let me know in the live chat. 20 valid parenthesis with a string S. Okay. We are given with string S. What does it contain? It contain open square bracket, closed square bracket, right? Now, for every open bracket, that's clear. It should be valid, right? So for every open, we need a closed one. For every closed one, we need an open one. So if valid, return true, return true, else return false. If, okay, determine if the input string is valid, that's it. So S is equal to open bracket and close bracket. Let us look at this example where we are given with S is equal to open bracket and then close bracket. First, we took this open bracket. For this open bracket, I need a closed bracket. So when I get this closed bracket, instead of checking for an open bracket, is there a closed bracket? So I think you got what I'm saying. Instead of checking whether whether we have a uh, closed bracket, can we take? Okay, I think your comment isn't completed, bro. Closed. Whether we have a closed bracket. After that, we three stacks for three different symbols. Okay. So three stacks for three different symbols might take, like I'm also thinking like that, but let's go with your approach. Let us take this example, open two open brackets and then like this. Now, okay, I went as unique because, bro, you have said that for this and then this. No, let's go in order. This and then this we are using three stacks. Now, imagine I got this, so I'm pushing one. Then I got this. I'm pushing 1. Now I got this. I need to check here. Okay, it is valid. I need to remove it. Now I got this. Okay, it is valid. So I remove this. So I got out of the boundaries. So I will return true, however. But what if I have like this? Uh, okay, let us take the same, no, this one and then this one. Okay, and then this one, then this one. At last, if all stacks are empty, then return true. Okay, let us see whether it is true or false. Let's just return it. Return true. Here, I'll be giving a test case. So, open bracket, then this, and then this. Okay, let us see whether is it a valid or a invalid string parenthesis. If you see, it is invalid. Why? Because it should have in the same order. So we have said that we need to use 3 stacks, but let us use those 3 stacks actually. Okay, you said at last if all stacks are empty, then return true. Okay, let us see how can we solve this as okay. Let us see. Now I'm pushing this back. Now I'm pushing this into this stack and pushing this into this stack. Now I have got this one closed bracket. I got yes, I have in this right. So what I'll do, I'll remove it. I'll just remove it, right? I removed it. Now let us go to the next one. Here I got this. Now let me check. Do I have an open bracket like that? Yes. Remove it. So going to the next one. Yes, I got an open bracket. Sorry, closed bracket here. So I'll check for open bracket. Yes, I have. So remove this and then this. So as you have said that at last, all the stacks are empty. If you see, all the stacks are empty. If I took 3 stacks, all the stacks are empty. I think this doesn't work, right? What are your opinion? What is your opinion on this, brother? Right? Okay, okay. Let us see. So what I'm thinking is instead of checking whether we have a closed bracket after that, we check an open bracket previously. Let us see. Let me take the same example like this. Wait a second. Open bracket, square open bracket, sorry, square open bracket, and then floor open bracket, then square close bracket, floor close bracket, and then close bracket. Now, what is my intuition is, let me take a stack like this. We take a stack like this. I'll see that let me go and iterate. I got here opened. Okay, just open brackets. Let me state as open brackets. I have pushed this. Now I got it is open. Then let us push that. Now again push this. Now I got the closed bracket. But if you see, if I just changed the order, if I just replace these two, I would get a, you know, like what do you say? A true. But here it is not the case. I got a square closed bracket, but on the top I got flower open bracket. So I'll compare the top with this one. Do they match? No. So what I'll do? Return false itself. return false here. That's what expected, right? So expected false. Let us just change the example like this. Open bracket, open square bracket, closed square bracket, open closed bracket. Then open floor bracket, again open floor bracket, open square bracket, then open floor bracket, okay, open floor bracket, then closed closed bracket, then closed square bracket. Then let us take again like this and then like this. Let us see what it happens. Okay, first I need to make sure that whether is it a true or not. Let me know, is it a valid parenthesis or not? Is it valid parenthesis? Let me know in the live chat. So I need this in a session to be interactive. So we'll be solving this in just 4 minutes, however. Is it a valid parenthesis or not? I need to get this answer from you. Valid. Okay. So I need to get the stack so that it should be valid, right? I need to get the stack so that it should be valid. Let me tell you, how can I get it? So we have concluded that it is a valid parenthesis, but will my intuition work for this? Let us see that. So all the open brackets, I need to push that back into this stack. So open, okay, open, okay. Now it is closed. Take this top, I got this. So if I got this, the reverse of that, if open, so I got a closed bracket. So I'll check whether the top is the reversed, the same type of bracket open. Yes, I got it. So what I'll do, I'll remove this. Now, closed bracket, okay. Close bracket, here it is open, so let me remove it. Now, open bracket, push that. Open bracket, push that. Open bracket, push that. Open bracket, push that. Now it is closed. Now for this closed, I need to have the open bracket here. Yes, I have. So pop from the stack. Now it is a closed. For this, I need a open bracket on the top. Is it open? Yes. So what we'll do is we'll pop from the stack. Now, if you see here, here it is open. What I said, every time if it is open bracket, push that back into the stack. Okay. Now it is closed. For closed, on the top, I have open bracket, right? So if it is open bracket of the same type, then remove from the stack. Now close bracket. On the top, open bracket on the top of the same type. So what I'll do, remove from the stack. Then close bracket here, open bracket on the top of same type. So what I'll do, remove from the stack. Now imagine, just imagine that I got two more open brackets like this. What we will do? We'll push that back here. But these are not closed. So how can I write the algorithm for from this? First, how can I write the algorithm for from this is initialize a stack, iterate the string. So I have initialized the stack and iterated the string. Stack was initialized and then iterated the string. If it was open, pushed back into the stack, no matter if the bracket is open, push into stack. Now, else it is closed, right? If else it is closed, right? So here there will be two cases. If the top uh, top open bracket, right? Top bracket is of same type, same type, pop from the stack. Now, if it is not of the same type, else what we need to do? Return false. Okay, I think you have understood this. So if the bracket is open, push into stack. Now, else if it is not open, if it is a closed bracket. So I need to check if the top bracket is of same type, pop from the stack. Else return false. Have I iterated the string correctly? Then if stack is empty, return true. That means it is a valid parenthesis. If not, we will return false. I think we got all the edge cases covered. There might be an error. Please don't take me uh, wrong. There might be an error in this algorithm also. I am not an expert, just learning, right? Okay. Okay, let us see. Let me write the same algorithm into the code. Let us write the same algorithm into the code. Let us see. How we started here? We started with initializing a stack and then iterating. First, we need to take the size of the string. So int s n is equal to s dot size. Iterate the string for int I is equal to no character. Character C in S, but before that I need to initialize stack. Character st. I'm naming it as st, right? If the bracket is open, if C is equal to open bracket like this, or C is equal to open bracket like this, or C is equal to open bracket like this. If these are the cases, then st dot push C. Else, I need to have first thing. If C is equal to this open bracket, simple open bracket, and st dot top is equal to the close bracket. But I'm checking for st.top without checking whether stack is empty or not. So stack is not empty and this is true. Or I will copy this and this and then this. Right? Okay. I'll just change this like this, right? Okay. Let us see. Let me just format this code. It's looking clumsy. Okay. If st, the stack is not empty, I need to mention this in the algorithm, but I have forgot it. C is equal to open bracket and st dot top is close bracket. C is equal to open bracket of the flower type and st dot top is the closed bracket of the same type. C is equal to square open bracket and st dot top is square close bracket. So if this is the case, then st dot pop, that means removing itself, else I need to return false. If st dot empty return true, return false at the end. Let me run the code. I got an long answer here. If the bracket is open, push into. Okay, right. Then else. st.top. Sorry, have made a mistake here. Instead, I need to place C, Control C, C, and then here this. Wait a second. And then here I need to place C. Here I need to place st.top. What I did here is a blunder that instead I placed in reverse. At the place of C, I placed st.top. At the place of st.top, I placed C. I think it's correct now. st.top is equal to open bracket and C is equal to close bracket. st.top is equal to open bracket and C is equal to close bracket. st.top is equal to open square bracket and C is equal to closed square bracket. st.pop. That means remove that. If it is not true, if anything of this is not true, no. I need to place, here I need to place all will not be valid, right? Or st.top is equal to open bracket and C is equal to close bracket. Or then here also or, that's it. Let me run the code. I hope it accepts. Yes, it got accepted. If you have any doubts, let me know in the live chat. I thought we will be solving this in 15 minutes, but it took 8 minutes more. However, we got understood. I'm submitting the code. Okay, it got accepted. Excuse me. It got accepted. Yes. So I'm having a target of 830 subscribers. Don't know whether we reach that target or not. Okay, after valid parenthesis, we'll be solving like another problems also about stack. Let us see. Let us see how can we solve minimum stack. So I think I've searched about this question, right? Let us see. What are they asking and how can we solve this problem? Excuse me. Okay. So design a stack that supports push, pop, top, and retrieving the minimum element in constant time. Implement the minStack class. MinStack initializes the stack object. Void push into value pushes the element value onto the stack, right? Okay. What do you think? Right? Void push pushes the element value onto the stack. Then void pop removes the element on the top of the stack. Int top gets the top element of the stack. Int get minimum retrieves the minimum element of the stack. So every operation has to be performed in big of one time complexity for each function. Let us see how can we solve this actually. So here is the function void push. We need to push back. Void pop. We need to remove the last element. Int top. We need to retrieve the topest element. Int get min. So let us see. All these again. Let us see how can we solve this. So push for three times, get minimum, push, and then get minimum, and then pop, top, and then get minimum. Okay. Then minus, okay, sorry, minus 2 and then 0 and then minus 3. Then nothing here, nothing, 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 nothing. Okay. First, in the stack, let us see how can we see it. Push minus 2. Okay. I have push minus 2. Then push 0. Okay. Push minus 3. Okay. What if they ask for get minimum? Is it minus 2 or minus 3? It is minus 3. Yes, it is minus 3. But if I create an array from this stack, it will take big O of n time complexity, however. But we should not do it. We need to take big O of 1. But instead, let us see. When I pushed back minus 2, what was the minimum value? Let me tell you, the minimum value is minus 2 itself. Now, when I pushed 0, the minimum value in the stack, if I even pushed minus 2, even if I pushed 0, sorry, even if I pushed 0, the minimum value in the stack is minus 2 itself. Now, I want to push minus 3. I'll push it. But after pushing minus 3, what will be the minimum value? Will it be minus 2? No, it will be minus 3. Now, when I asked with get minimum, then what is the minimum value here? The top element, when it was pushed back, the minimum value was minus 3. So here I'll write minus 3. Now they are asking us to pop an element, the top element. What I'll do? I'll just remove this. Let me do that. Remove that from the stack. Okay, I have removed it. That's it. Remove. Now we are asking for top element. When was this top? The top is here, 0, right? Okay, I'll just return the 0 here. Now it is asking us for get the minimum value. So we got this, we got 0 and 2 itself in the stack. So what is the minimum from these two? Minus 2. It was already stored in the stack, right? 0 comma minus 2. Here I am storing minimum. So here I'll store value comma minimum, excuse me, value comma minimum value. So I'll return minus 2 here. How can we use this? We'll use vector. How can we implement it? So we'll be using vector of vector int, and let's say that stack. Now, when we are asked to push a value, I want to get the minimum value. So I'll get the minimum value by getMin function. Get minimum function, right? So if you see, like I want to get st dot push, I need to push back, right? I want to push back, so I will push back with the minimum value. I need to check whether this value is minimum. So if if st is empty, the stack is empty, or the value, the current value is lesser than minimum value, then minimum value is equal to value. That's it, right? So if value is lesser than minimum value, I'll change it. Even when stack is empty, then I will also change my minimum value. Then st dot push, this is a vector of vector int, so we'll be pushing that as a vector, this one, value comma minimum value. Now we have implemented push operation. What about the next operation? Pop. So for pop operation, we'll just pop the last element, st dot pop back, right? That's it. Will be removing the last element. What is the top element? The top element is nothing but return if st is empty. What if it is the stack is empty? Then we'll return -1 itself. If not, we'll return st dot back, the last element. What is the first element in it? 0. It is at index 0. This is top. Now, what if they asked for get minimum? So it will be a return st dot back of 1 only if st is not empty. So if stack is empty, if the stack is empty, then return maximum. If not, st dot back. Right, this is how we solve this. Let me do the code part. If you have any doubts, please let me know in the live chat, right? Chat, chat box actually. Void push here, int minimum value is equal to get min if st dot empty or values lesser than minimum value, then minimum value is equal to value st dot push value comma minimum value, right? Is there anything else? No. In pop operation, st dot pop back. That's it. In the top operation, return st dot empty. If it is empty, return -1. dot back 0, right? Sorry, get minimum. We need to return if st is the stack is empty, then return minus 1. If not, st dot back of 1. Let me run the code first. I think there will be no error. st dot pushback. Sorry, it should be pushback. Why? Because we are using vector of vector int. Okay, it got accepted. Only one test case. Okay. If you have any doubts, please let me know in the chat box. Yes. Okay, I think I'm clear to you. The audio is good, right? The audio is okay. Okay. I think we can go to the next problem. Yes. I think after this, I'll take a 15 minutes of break, right? Okay. The problem which we are going to discuss is evaluate reverse Polish notation. So this is also about stack. Evaluate reverse Polish notation. Here, if you see, the valid operations are plus, minus, multiplication, and division. Each, okay. First, let us come with, okay, it is, you are given an array of strings tokens that represent an arithmetic expression in a reverse Polish notation. Evaluate the expression. Return an integer that represents the value of the expression. Note that the valid operations are plus, minus, multiplication, and division. Each operand may be an integer or another expression. The division between or another expression, right? The division between two integers always truncates towards zero. There will not be any division by zero. That means we will not be dividing by zero. The input represents a valid arithmetic expression in a reverse Polish notation. The answer and all the intermediate calculation can be represented in 32-bit integers. So we don't need to get to any long or any other data type. The tokens dot length is 1 to 10 power 4 and tokens of I is either an operation or an integer in the range minus 200 to 200. Okay, let us see this first. Let us take an example 1, 2, and then plus. Okay, let us take evaluate reverse Polish notation. Evaluate reverse Polish notation. First, you are given an array, okay, everything is perfect, right? So 2 comma 1 plus 3 star. How can we evaluate this is 2, okay, I'll write it, and then 1, okay, I'll write it. Now it is saying that plus. Take these two numbers, add it, that's our result 3. So till here I got the result 3. Now I got 3. Take that 3, now I got asterisk, I think. Okay, asterisk it is. Now 3 and 3. Put an asterisk between them. What is the result? 3 into 3, 9. Return the 9. That's it. This is how easy it is. We need to implement stack, however. I'll tell you how. 4, 13, 5 are divisible forward slash and then plus. First, 4 and 13, right? First 4 and then 13. Let us take 4. Let us take 13. Let us take 5. Now it is saying that divide. This is the first number. This is the first number. Let us name it as A. And 5 is our second number, right? So 13 is A and 15 is B. We always do A operation B. Let me remember with this is the point that need to be remembered. So A and then operation and then B. So 13 by 5. What is the result? 13 by 5. 5 twos are 13. Okay. Now what I'll do, I'll use a stack and take out this A and B. What is the result? It is 2. So 2 is pushed back. Now it is saying that plus. Do the same thing. This is A, this is B. What is the operation between them? A plus B, nothing but 4 plus 2. And the answer is 6. Okay. How can you write the algorithm? If you see, If you see, I can write the algorithm very easily. So it is just an easy problem, right? We have got the edge cases. The first one, which is popped back from the stack, will be B, and the second one, which is popped back, will be A from the stack. So we need to initialize this stack first. So initialize stack of, what do you say, int, all are integers, right? Let me name it as st. Now, for every token in tokens, I'm through, just iterating through every tokens, right? So if let us say that if the token is equal to plus, right? Okay, if the token is equal to plus, what I need to do? I need to do the operation. So for that, int b is equal to st dot top, the topest element, and then remove that. Take the top element and then remove it. Int a is equal to st dot top and remove it. Then st dot push first element is a, right? A plus b. Now else if token is equal to minus, there is an operation with minus, right? Minus int b is equal to st dot, let's take the same thing and copy the same thing and paste it here. Int b is equal to like this. Okay. Else if else if token is equal to multiplication operation, then do the same thing here. Instead of doing subtraction, we are doing multiplication. That's it. Instead of subtraction, do multiplication. Else if token is equal to division, do division. We'll do division here. A by B. Now I have did the operations. What about the tokens which we will be pushing back, right? st dot push a by b, st dot push first element is a and then the second element is b. Now, what if I get a number, then else in that case st dot push string to integer token, right? So after that, return the element which we got in the top of the stack. So let us solve this in the code. It is so long, right? Yes, it is the same code, right? But it might look like a longer one. But we are having four cases, so that's why it might look like a long code. But let us see. this. Okay, let us do our code part. First, I will be initializing stack of int st for int token in tokens. If token is equal to plus int b is equal to st dot top st dot top. Then int a is equal to st dot top and st dot remove that. St dot push a plus b. Okay. Else if token is equal to minus. Else if token is equal to asterisk. Let us go there, bring it down. Here minus, here asterisk. Else if token is equal to division. Here also we'll be doing the division. Else st dot push stoi token. At the last return st dot. Let me do a run on this. Token and tokens. Sorry, string. Right? Okay. Is a spelling mistake. Else. Okay. I have run the code. So it got accepted, right? Let me submit it. So what we have done here, we are going through a big of n itself and pushing in the stack and also removing from the stack takes only big of one time complexity. If you see here, we are doing big of n as there are the size of token is n and big of n space complexity as we are. There might be a case, right? Okay. There might be a case that half of the uh, tokens are all the numbers and the remaining half of this will be like operators. Then we can say in a worst case we can go the space complexity can go to big of n. So if you have any doubts, let me know in the chat box. Right? Okay. So we'll be taking a break at 9:45 to 10 p.m. Yes. If you have any doubts, let me know in the chat box. Let me connect the charger. Right. Okay, you can ask your doubts in these 15 minutes. It's already night, right? Let us start discussing about queues. Like I have already said you about queues, right? So let us recap that what I said about queues. Now, queues is nothing but we will be in standing in a queue in an office or in a bus stop or something like. So the one which goes first will complete his work and then will get off that queue. The one after that, get off that. One after that, get off that. So this one is called as first one. First one goes and get his work done and leaves. Right? I think it's clear. First one goes and get his work done and leaves. Wait a second. Now after that, the next one, the one which came after the first one. He comes and get his work done and leaves. So if I write it in another way, first one goes in and get his work done, work done and goes out. So if we have to be clear, first in and he is the only one going out. So first in, first out, first in, first out. Okay, I think it's clear for you. Okay, first in and first out. This is the operation we'll be using for queues. If you have any doubts, please let me know in the chat box, right? Okay, I need to decrease the font size. Like, okay. First in, first out. If you have any doubts, let me know in the live chat. So the one which comes first will be removed first. Okay. So if this is our queue, if this is our queue, if we push back an element E1 into the queue, then E2 into the queue, and then E3, so the removing process will also be from the front. We'll be removing it from the front. Then after that E2 and then E3. So this is called front and this is called the rear. The one which is at the front, right, which will be coming at the front, the first element will come at the front, right, that is called front and the last element is called rear, right? I think you have understood this. Let me know if you have any doubt. Okay, let us see how can we solve. How can we solve implement q using stack. Okay, we need to use stacks, right? The one which we push back first need to be okay, need to be removed first. Okay, let us see that what if we use we need to implement queue using stacks, right? Okay, let us take 1, 2 and then 3. Okay, let us push back 1. If I used a stack, I'll push back 1, uh, then I'll push back 2 and then 3. Okay, but if I want to get the first element, then I cannot get without iterating through the whole stack. So we can implement that actually. What we'll do is this is stack 1 and this is stack 2. So push operation, push all elements into st1. Pop operation, for pop operation, push all elements into st2 and remove the top element. Then push st2 elements again into st1. So if I was asked, then here it will be 3 and then here it will be 2, here it will be 1, so it will be removed, then 2 will be inserted and then 3, right? So this is how we pop. Now if I want to get the peak element, so to implement peak, what I'll do, 2 and then 3, right? Just do the same thing, 3 and then 2 into st2, st2. This is st1 and this is st2, right? I think it's clear. Now this is the peak element, then after returning the peak element 2 and then 3, this is empty, st2. st2, right? So this is how we get it. So we will be initializing 2 stacks. st1 and st2. Void push. So what we'll be doing is push back into st1. st1 dot push x. Now to remove to remove to pop back, what I'll do, while st1 is not empty, while st1 is not empty, what I'll do, int x is equal to st1 dot top. Now st2 dot push x st1 dot pop st2 dot push. After that st2 dot pop, and then while st2 is not empty, then int x is equal to st2 dot top and st2 dot pop and st1 dot push x. Right, we are just removing an element st2 dot pop. If st1 is empty, return, we need to return, okay, pop into top is equal to st2 dot top. We'll return that, return top. Okay, we'll return -1. Okay, what about peak? We'll just take this and paste it here, but we'll not remove it. That's it, bool empty. If st1 dot empty, we can return here itself, return st1 dot empty. Yes, it can get accepted. Yes, for now today it will be itself, till here itself. Our class should be till here itself. So ending the session, ending the session at 10:30 p.m. Ask your doubts. If you have any doubts, please let me know. Right, about DSA or stacks and queues. Ask your doubts in live chat. So if you are hesitating to ask in the live chat, I'll be giving you the link of my LinkedIn profile and also my Insta profile. Right. linkedin.com/in/. Okay, this is my LinkedIn underscore R. So this is my Insta profile. I'm also giving you my Insta profile. So you can directly message me there. Okay. So we'll be ending this at 10:30 p.m. If you have any doubts, please let me know in the live chat.